Ain't no mountain high enough. Ain't no valley low enough. And ain't no river wide enough to keep me from getting to you. Oh, we're live. Oh, wow. That's very embarrassing. I apologize. Didn't know we were live. Yeah, this is Precal 5.3. I'm sorry. I'm sorry today. Hopefully you didn't see that. If you did, I completely apologize. You can just skip 30 seconds in. You didn't need to see that. Right now, you're here in my living room with me and my Mac and Monday Night Football. Just watching some football right now, and thought we'd knock out a podcast. I've got 4 problems to go through, section 5.3. Hopefully you're doing that. Again, it's on the calendar if you forgot it. If for some reason you need some extra copies, it's in the back section. You can kind of check that out as well. Hey, let's get right straight to it. Section 5.3. Let's get to those 4 problems and let's go from there. Hey, the first one that I found was one that we did yesterday. And man, I heard a lot of you say, man, coach, we got a lot done, and we really, really did. And so thank you so much for your effort. Really, this is just for help if you need it. If you do not have to watch this, but it's something that hopefully will be of help to you. The first thing we have to do is look to see if we can factor. And since we have both of these factored out, we can set both sine of x and sine of x plus 1. We can set both of these equal to 0. Now, what happens when we set both of these equal to 0 is we can solve for 2 separate solutions. Because this is not between, I think the instructions said all intervals, right? So it's not just between 0 and 2 pi. We can solve for where sine of x is 0 and where sine of x is equal to -1. So I look at my unit circle and notice that anywhere that's on the x-axis is a place where the y or the sine of x will be 0. So those places are at 0 and at just pi. Okay, so at 0 and pi, there is sine of x is going to be 0. And then the next question is where sine of x going to be equal to -1? Well, because sine of x is -1 only at one spot, we know that it's at 3 pi over 2 is that it's at that specific location. So what I have is I have 3 answers, 0, pi, and 3 pi over 2. Now, because there's nothing that's linked with x, the period is just 2 pi over b, in this case just 2 pi. So I'm going to add 2 pi n, which is the period. I'm going to add 2 pi n to each of these 3 answers. So really 0 plus 2 pi n, if I really was being specific, I'd have 2 pi n, okay? I'd have pi plus 2 pi n, and I'd have 3 pi over 2 plus 2 pi n. And those 3 answers would end up being the answers that we would have going forward. Within the next one, let's go to the next one. I feel like Dora the Explorer, because like I'll ask a question and then, you know, I don't know. I'm sorry. I just got off on a tangent there. No pun intended. All right. So cosine of to the third x equals cosine of x. So right now in class, I don't want you might think, man, this is really weird. Right now, I want you to tell me right now, talk to your Mac right now. What would you do to solve this problem? Right now, talk to your Mac. Yep, don't look at me weird. Yes, you, Teresa, don't look at me weird. Right now, I want you to try to solve for this problem. What would I do? Makai, yes, you. Yep, Madison, you too. Okay, we're going to subtract cosine of x to this side to get it equal to 0. So what we would have is cosine to the third x minus cosine of x. Now, because I've taken everything to that left side, what do we do next, Buck? Yep, answer it. You're exactly right. We're going to end up taking a cosine of x out on that left side to where when I factor it, what's left over? Cosine squared of x minus 1 equals 0. So since I factored now we can set both of these equal to 0, just like we did with the sine. All right, subtract there. There we go. And now we can solve. So cosine of x equals 0. We've got that there. And just like with sine, cosine of x would be 0 on the y-axis. So it would be at pi over 2 and at 3 pi over 2. Okay, let's look at the next one. Where would cosine of square root of x equal 1? Because I add 1 to both sides. Square root both sides. And so I would have the square root of 1, which is 1, equals cosine of x. Now, I'm missing something. What am I missing? Oh, nicely done. Nicely said. Stephen, nicely done. Chris, nice done. Yep, it would be plus or minus here. It wouldn't just be 1, but it'd be plus or minus 1. So where's cosine of x plus or minus 1? Well, my answer would actually be on the x-axis, and it would be at 0, and it would be at pi. So 0 and pi over 2 and 3 pi over 2 are our 4 answers. And then what we're going to do is we're going to add 2 pi in because there's nothing else that's linked the period would be 2 pi over b because the b is 1. It would just simply be 2 pi, and we just add 2 pi in to it, okay? If this was one that it said only 2 intervals, then what we could do is we wouldn't even need to, or if it's at the interval of 0 to 2 pi, we wouldn't have to use this, but I forget which ones I said on there were and were not. So we'll just say that it is for right now. All right, our last two are ones that aren't difficult here, but it's ones to remember. Remember at tangent of 3x equals 1, where is tangent first equal to 1? Well, there's 2 places, right? Quadrant 1 is the first place, and the second place would be at quadrant 3, okay? Quadrant 1 and quadrant 3. So because of that, where is it going to be 1? Well, it's going to be at pi over 4. Okay, pi over 4 is the first place, and the second place would be at 5 pi over 4. Okay, so these 2 locations at 5 pi over 4 and at pi over 4 would be the 2 locations where tangent of x equals 1. But we've got to take now these problems, or these answers, 5 pi over 4 and pi over 4, and we've got to set them equal to 3x. So we set them equal to 3x and multiply by 1/3 on both sides. Okay, multiply by 1/3. Okay, gone, 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 gone. To where x is now equal 5 pi over 12, and x is equal to pi over 12. So we know these 2 would be our answers, 5 pi over 12 and pi over 12. And when I end up solving for those, I leave those as my answer, but now I've got to add my intervals to it. Well, now we've got to figure out what is the period. Well, remember the period is 2 pi over b, traditionally, for sine and cosine. But because it's tangent, it's actually going to be pi over b. Well, b in this case is 3. So really my period would be pi over 3. So what I would do is I would add pi over 3 with an n on the top. So pi n over 3. And I would add it to pi over 12 and 5 pi over 12. And that right there would set myself up for my answers there. Okay, that's how I would solve for those there. All right, and you could go back if you really need to on that. But what we'll do is we'll keep going forward here. Let's see. Oh yeah. Come on, pen work. There we go. Excellente. You ever just feel like breaking out in song? Don't you wish that sometimes we just lived in a high school musical world? Could you imagine just singing every lesson? It'd be awesome, you know? I think it would be awesome. I don't know why. I don't know why I thought that. Anyway, my fault. Next one, what we're going to do is we're going to change one of these, secant squared or tangent squared, to the opposite one by using Pythagorean identity. Now, remember the Pythagorean identity is 1 plus tangent squared equals secant squared. Well, if I took 1 plus tangent squared and plugged it in for secant squared, here's what I would have. I'd have 2 times 1 plus tangent squared. You could do either or, by the way. You could isolate tangent too. All right? It could, as long as it's all by itself. All by myself, don't want to be. Yep, as long as they're by itself, we're good to go. So we have 2 plus 2 tangent squared plus tangent squared minus 3 equals 0. Again, all I'm doing is isolating one of them. And once I isolate them, let's combine like terms. So let's go tangents, whole numbers together. So I get -1 equals 0. 2 tan squared plus tan squared equals 3 tangent squared. Nicely done. So once I add 1, I'm then going to divide by 3 to where now tangent squared, I can't write that low, but I'll put it right here. Put it right up here. Tangent squared equals 1/3, okay, by adding 1 and dividing by 3. So I'm going to square root both sides. When I do, I get tangent equals plus or minus square root of 1 over square root of 3. Now, square root of 1 is 1, so what I really have is plus or minus 1 over square root of 3 equals tangent. Now, because the square root of 3 is on bottom, I multiply top and bottom by square root of 3, and I'll keep going downward down here. Now I have tangent is equal to plus or minus the square root of 3 over 3. Now, here's where a lot of people struggle, okay? Where is tangent square root of 3 over 3? Now, remember, square root of 3 over 3 is related with 30 degrees, right? So come up here, 30 degrees is related to square root of 3 over 3, or we could say this is pi over 6, right? And at pi over 3, which is 60 degrees, that is just square root of 3. So where is tangent going to be square root of 3 over 3? The answer is going to be at pi over 3, or at pi over 6, I'm sorry, because it's at 30 degrees, right? Square root of 3 over 3. At pi over 6, what I'll do, I'll put them up here. Put them over here. Pi over 6. Next one would be at 5 pi over 6. So we're just going around the unit circle. Remember, plus or minus. Next one, 7 pi over 6. And last one would be 11 pi over 6. Now, what do I add to it? Well, because there's nothing related to x, it's only what you see is what you get. Since tangent has a period of 2 or just pi, since it has a period of just pi, all we're going to do is add pi in. And I think in this one you have an interval of just 0 to 2 pi, but just in case. Those would be our answers there for the 4 on that problem. Y'all, I hope you understand it. Man, I really hate missing today. If there's any questions at all, please don't hesitate to contact me and let me know. I'd be glad to try to get those answers to the questions that you have. But overall, I think we should be fine. This should be posted on Tuesday at midnight. Which is tonight at midnight. So make sure you post that. Other than that, have a fantastic, wonderful, wonderful, wonderful day. Know I care about you. Can't wait for block day. Have something really cool planned. And I'm really excited to be able to do that with y'all. All right. See y'all. Have a happy homecoming week. Bye now.